Hey Ramsey fam! Welcome back to today's video. We're going to look at chemical bonds, Valence Electrons, and listen to the periodic table song by A$AP Rocky because I love that song so much. If you don't remember how to read a periodic table or you need more help with chemistry, check out my chemistry folder or comment the questions you have. So, atoms don't like to be unstable. They want a full outer shell. They want to fill their outer shells. So they bond with other atoms to fill their outer shells. And there are three main types. We have the ionic, covalent, and metallic bond. Starting with the ionic bonds, they are transfer of electrons. They usually happen when one atom donates its electrons and another accepts it. Okay, take fluorine and lithium for an example. Lithium has 1 valence electron, fluorine has 7. It's easier for lithium to get rid of its 1 than gain 7, and it's easier for fluorine to steal that 1 rather than get rid of its 7. That's an ionic bond. So this usually happens between a metal and a non-metal. The metal loses electrons and it becomes, lithium is the metal, and it becomes a positive ion, which we call a cation. And fluorine loses electron, which we call fluorine gains electron and it becomes a negative ion, which we call an anion. Because they have opposite charges, they attract like magnets. For example, sodium, no, let's say aluminium. Aluminium has 3 valence electrons and chlorine has 7. Aluminium is going to give chlorine 1. Chlorine is okay. Another chlorine will come over. That's 7. Aluminium will give this another 1. And another chlorine would have to come over. And aluminium will give chlorine 1. And it will be Al3 plus Cl minus. Okay. Covalent electrons. Covalent bonds, not electrons. Okay, before we move on to covalents, aluminium gives 3 electrons to fluorine, and now both are stable. This forms AlCl3. Why? Metals want to lose electrons to empty their outer shells, and non-metals want to gain electrons to fill theirs. Okay. Covalent bonds are sharing electrons. They share their electrons. It happens between 2 non-metals. Instead of transferring, they team up. For example, fluorine and chlorine. They both need 1 more electron. So they grab one from each of theirs. They have two, and it just that kind of like floats in between them like this, and they're connected. Instead of transferring electrons, they team up and hold the electrons between them, and this creates molecules, not ions. The atomic elements, the way I remember them by is off Brinkel. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine are all examples of covalent bonds because they exist as twos, not ones. And this creates molecules, not ions. For example, hydrogen has one, oxygen needs two, oxygen has six. Oh, that's not really that. Oxygen has six, so hydrogen would give one to oxygen. Another hydrogen will come over and give it to oxygen, and we'll be left with H2 because we gave two oxygens. Yeah. And each hydrogen shares one electron with oxygen. They bond like this. Hydrogen, hydrogen, oxygen. 1, 2, 3, 4. You have a one. You have the one. And that's how they bond. Covalent bonds are found in gases like H2O, like O2. H2O is not a gas, it's a liquid. Like O2, oxygen gas, carbon dioxide, and in most biological molecules. There's also metallic bonds, which we won't get into, but it's basically free floating electrons, and they occur between two metals. Usually transition and transition metals are a different breed. The outer shells don't stay with one atom, they float around like a sea of electrons. This allows metals to conduct heat and electricity. Where were we? Okay. This allows metals to conduct heat and electricity, be malleable, and be shiny. A bar of copper, the electrons are free to move through the metal. That's why copper wires conduct electricity. Okay, so think of metallic bonds like a potluck where everyone puts their food, electrons on the table, and they all share. Valence electrons. Valence electrons are the electrons in the outermost energy level of an atom. These are electrons that participate in bonding. You can find valence electrons by looking at the element group number like we talked in the last video. The one just above this. I'm just going to erase all this and use this spot because I need my periodic element, my periodic table. That's tiny. Okay. Group 1 valence electrons. Group 2, we're going to skip through 3 to 12 to 13. These both form ionic bonds plus this group 13, which has 3 valence electrons including 1, and this is 15, 16, and 17. They gain electrons, and this either gains or loses Depends on whatever it feels like. It's like right smack in the middle. Smack top. Then group 18 have full valence electrons. They are noble gases and they already have a full shell. Group 17 are so close to a full shell that they react quickly, especially with group 1 metals. Group 1 and 2 form ionic bonds with non-metals to become stable. Remember, if an atom has 1 to 3 valence electrons, it wants to lose them. If it has 5 to 7, it wants to gain electrons. And if it has 8, like neon, it is happy and it doesn't react. It is called the octet rule. Atoms want 8 valence electrons to be stable, except from hydrogen and helium, they only want 2. And lithium and beryllium, because they have 3, and when lithium has 3, beryllium has 4, and when they lose their electrons, they go down to 2. So it's 2, then 8, then 8. That's how the valence electrons go. And boron too. Boron is a metalloid, which is either a metal or a non-metal depending on whatever it feels like. Okay, let's watch periodic element video.
And now, ASAP Science presents the elements of the periodic table.
There's hydrogen and helium, then lithium, beryllium, boron, carbon everywhere, nitrogen all through the air with oxygen so you can breathe, and fluorine for your pretty teeth, neon to light up the sign, sodium for salty times,
Magnesium,
aluminium, silicon,
phosphorus,
then sulfur, chlorine, then argon,
potassium,
and calcium so you'll grow strong,
scandium,
titanium, vanadium, and chromium, and manganese. This is the periodic table. No gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells while electrons are added, moving to the right. Iron is the 26th, then cobalt, nickel coins you get. Copper, zinc, and gallium, germanium, and arsenic, selenium, and bromine, thermal, krypton helps light up your room. Rubidium and strontium, then yttrium, zirconium,
niobium,
molybdenum, technetium,
ruthenium,
rhodium, palladium,
silverware,
then cadmium and indium,
tin cans,
antimony, then tellurium, and iodine, and xenon, and then cesium, and barium is 56, and this is where the table splits, where lanthanides have just begun. Lanthanum, cerium, and praseodymium. Neodymium's next to promethium, then 62, samarium, europium, gadolinium, and terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium, hafnium, tantalum, tungsten, then we're on to rhenium, osmium, and iridium, platinum, gold to make you rich till you grow old, mercury to tell you when it's really cold, thallium, and lead, then bismuth for your tummy, polonium, astatine would not be yummy, radar, francium will last a little time, radium, then actinides at 89. This is the periodic table. Noble gas is stable. Halogens and alkali react aggressively. Each period will see new outer shells while electrons are to the right. Actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, isonium, fermium, mendelevium, nobelium, lawrencium, rutherfordium, wm, sprigium, borium, hesium, ligninium, obsidium, mercenium, copernicium, natrium, flerovium, pentium, livermorium, septium, noctium, and then we're done.
I have 11 protons and I am found in salty foods. What element am I? So if you guess sodium, you are absolutely correct. Let's go back to diatomic elements just a little bit. Did you know some elements travel in pairs? Me to diatomic 7, they are never alone in nature. That was how my teacher taught us in class. I told you about Off-Brain Cool. Did you know that diatomic means elements that naturally exist as molecules made of two atoms of the same element when they are in their pure form. In nature, you can never find these elements alone. They are all non-metals and they are always found in gases except from bromine, which is a liquid, and iodine, which is a solid. Next time you write a chemical reaction, remember these 7 elements: hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, 1, 2, 3, 4, 5, 6, offering cool, and chlorine. And do not leave them single. They love their company. Next time, we are zooming in on the atomic structure, protons, neutrons, and electrons. We're going to look at Bohr diagrams and how to find their numbers using the periodic table. Let's look at Bohr diagrams. We are also going to look at Lewis dot diagrams, which is the valence electrons only. And then Bohr diagrams are like the full electron shell layout. And if you miss anything, you can always check my chemistry playlist. That will be right around here somewhere. That'll be right around here somewhere. And don't forget to subscribe. And I will see you next time. Bye.